So to review, we have gone over the outline of what this meeting is and needs to do. We've gone through the video. We've looked at all the ways in the game to score, all the ways to lose points, what the game pieces are, what the arena looks like and its dimensions, etc., where the robots can begin, and we've looked at what advantages the arena inherently gives to certain places and certain actions. And it is only now that we've done all of that that we can start designing our robot and what we want it to do on the field in the game. If you jump to this point prematurely, or worse, if you start designing the robot itself, having the design definitions, or worse yet, prototyping components without even defining what the robot needs to have in it, before you even define what it needs to do, you're really going to be in a world of hurt and be questioning how you got to where you are week 6 when your robot isn't complete and doesn't do everything you think it ought to. So with that admonition aside, we've identified the game. We've identified what's ideal for a robot to do, and now for our robot to do. And so what is it about our robot that we want to build into it? So what actions are needed from our robot to achieve those things? So does it need to lift the game piece into a certain height? Does it need to pick things up from the ground? What actions are needed? And are any of those actions sequentially dependent? So these are still rather abstract. We're not saying that we're going to use this mechanism to pick up the pieces or this mechanism to place the game pieces. We're just saying we are going to place them, or we're going to shoot them, we're going to pick them up. This is still rather abstract. And we need to keep it abstract in order to get to a conclusion that everyone can stand behind. Are there any particular obstacles that the robot needs to drive across? That's going to be very important to the drivetrain. How fast do you want to go across the arena? These are questions that are being addressed in this sheet right here. And are there strategic compromises in any of these decisions? And this is something that is a real critical thing to acknowledge, is the value versus the difficulty linear? What does that mean? The sequential climb. So to get to the first level turned out to be really easy for most robots. Climbing to that second level was an entirely different challenge. And most teams would have to make an entirely different mechanism to do that second stage. And so we had to make a decision. Do we want to go for the first stage, second stage, all the stages? Is it worth it? So this is where all the meat hashing really happens. But you have to do everything else first. And are there any game design traps? So for instance, I was mentioning earlier, a couple years ago in Recycle Rush, there was a cooperation stack. And that was one that gave both teams a significant amount of value if both alliances contributed to it. But if it was very contingent on both alliances contributing to it. Worse yet, it went away in the elimination rounds. So if you got a high seed by doing that, once you got to eliminations, that value that your robot brought to the game disappeared. And so that was a bit of a trap. A lot of teams took, and ours included, took too much time for designing and building, as well as in the arena doing the cooperation stack. And it really wasn't worth doing at all in retrospect. And so watch out for these things. So after you've said, all right, what does the robot need to do? How would you roughly describe what it does? Then you can figure out the definitions. So it needs to have a chassis or doesn't need to have a chassis. Probably does. What does your drivetrain need to be and do? This is where you start specifying, your wheel size, your gear ratio. You may want to define your power transfer mechanism. That is chains versus belts versus gears. You might want to throw that into here. Mechanisms A, B, C, whatever. So if you're going to have a shooter, if you're going to have an intake, etc., what are the things that those need to truly do? And that then brings you to your prototypes. So you can properly prioritize your prototypes and get building, get testing, and get improving. So these last two sections, you don't record anything new necessarily into the spreadsheet here, but this spreadsheet is going to be critical in deciding these last sections. So I hope this wasn't too long-winded. I hope this is very helpful for you, and I hope this isn't too late in your build season to make you a stronger team and give you a better robot. So good luck. See you in the field.